In the vastness of the universe, there is a star unlike any other, a supermassive one called Betelgeuse. Behind the noble image lies a bomb ready to unleash a terrifying vision that could change our worldview. How can humans prepare for such a big cosmic event, and how will the Betelgeuse explosion change our understanding of the universe? Join us as we explore the mysteries surrounding Betelgeuse, a star that has fascinated astronomers and audiences alike. Betelgeuse, a giant red star located in the Orion constellation, has always fascinated us with its red glow and unusual brightness. Recently, however, new trends have increased our interest in this celestial giant. Betelgeuse is very large, about 764 times the mass of our Sun. Imagine a star so massive it replaces the Sun, and its surface extends beyond Mars, including Mercury, Venus, Earth, and Mars. But its large size is nothing, it's a sign of its place in the life cycle. Betelgeuse is so massive, its age is fading, it's slowing down, and it's cooling after a long time of burning hydrogen into helium in its core. At around 8 to 8.5 million years old, Betelgeuse looks young to the human eye, but in the astronomical world it is old. Born from the fire of a star nursery, the star emerges as a bright blue, hot star that radiates energy. But over the years, Betelgeuse changed and became the red giant that we marvel at today. This change is indicative of the dynamic interaction between two global forces, nuclear fusion and energy. In Betelgeuse's core, hydrogen atoms turn into helium, releasing enough energy to make the star shine. But as the star's nuclear fuel runs out, its gravitational force expands, causing the outer layers to expand outwards to form a planet. Unlike the Sun, which burns with a yellow-white flame, Betelgeuse's cold temperature is darker and redder in appearance, warming and mysterious to the universe. But the story of Betelgeuse is not a story of constant brightness, but a story of change marked by the story of human history. Ancient texts from cultures around the world describe the different colors of Betelgeuse, with stories of the star appearing yellow in ancient times before transitioning to its blood-red state. This movement is a vision of a journey that continues before our eyes. The beauty of Betelgeuse's sky contains a mystery, its brightness variability, which has puzzled astronomers for centuries. Like a similar variable star, its brightness fades in a spectacular celestial dance, flashing in rhythmic cycles across the sky. However, the dance of Betelgeuse is not just a dance, but an epic dance with unexpected movements. In late 2019, Betelgeuse unveiled its Big Bang, a global event that shook the foundations of astronomical understanding. The star dimmed at an unprecedented rate, decreasing by 0.1 magnitude per day until it reached its lowest brightness in February 2020. This great event, observed by many astronomers, aroused the imagination of scientists. Is Betelgeuse on the verge of a supernova explosion or just plain bad? As the moon travels through space, it takes 725 years for the light from Betelgeuse to reach us. Amid the global excitement surrounding Betelgeuse's vibrations, astronomers are left to ponder the mysteries of the universe. In an attempt to unravel these mysteries, Andrea Dupree, Associate Director of the Center for Astrophysics at Harvard and the Smithsonian, led his team for 3 years to study Betelgeuse using the Hubble Space Telescope. Their observation provided insight into the dynamic nature of the star. Like the heart of the universe, Betelgeuse expands and contracts, creating a combination of light oscillations. With Hubble's powerful ultraviolet light, researchers probed the intricacies of the star's atmosphere and discovered a surprising number of turbulent convection cells. Their findings revealed that material is moving from the star's surface to its outer regions at 200,000 miles per hour. This ejection of hot and dense matter spread out over millions of miles, representing the formation of the magnificent dust cloud that enveloped Betelgeuse in its cosmic mantle. Dupree's calculations showed that the previous wave of material, twice the previous size, had erupted from Betelgeuse's southern hemisphere within 3 months. As the dust settled, astronomers marveled and humbled the majestic dance of the interstellar forces that govern our vast and wondrous universe. Betelgeuse's massive loss, while not unusual for stars, was notable for its size. This sudden loss of material and the subsequent decrease in its brightness caused a debate among astronomers around the world, leading to speculation about the death of the star. Is this dark event a sign of a long-awaited supernova or just a short-lived phenomenon? Among the speculations, a question arises. What does this event foretell for Betelgeuse's future? Is this a sign of an impending explosion, or just a temporary anomaly in the star's life cycle? Several theories have been proposed to explain this confusion. Some believe that this is an important event for the explosion, while others believe that the thick cloud of dust from the material of the star hides the brightness from our view. A third theory suggests that changes in Betelgeuse's photometry, the visible outer layer, affect the brightness. To solve this cosmic mystery, astronomers turned to a variety of observational methods, including spectral studies, which revealed a significant drop in Betelgeuse's effective temperature. These studies made a surprising discovery. The phenomenon of migration coincided with a significant decrease in temperature, suggesting a large dark spot on the surface. As the story unfolds, the puzzle of the Betelgeuse mystery begins to unravel, revealing fascinating insights into the complex workings of stellar events. Finally, this mystery was solved with the great help of Hubble Space Telescope. Hubble's observations revealed the probable cause of Betelgeuse's dimming, a massive ejection of material that created a thick cloud of dust covering a large part of the star's surface, reducing the amount of the moon reaches the Earth. The dust cloud appears to be caused by superheated plasma erupting from a large convective cell on the star's surface, which cools and turns into tiny dust particles, forming a cloud that darkens the light from a quarter of Betelgeuse's surface. The size of the launch was astounding, 400 billion times the mass released in the supermassive launch, equivalent to many times the size of our moon. This event is not only important to Betelgeuse, it also provided a deeper insight into our understanding of stellar mechanics. What does this massive ejection of material mean for Betelgeuse and general theories about supernovae? The implications are profound. Older theories suggest that red masses like Betelgeuse are still missing before their explosive deaths. However, the magnitude of this ejection challenges this assumption and points to an infinitesimal dimension that cannot be seen for these stars. Recent studies suggest that Betelgeuse will explode much faster than previously predicted, possibly within decades. As Betelgeuse races through space at approximately 67,000 miles per hour relative to its surrounding interstellar medium, it generates a phenomenon known as a bow shock, similar to the wave formed by the bow of a moving ship. This extraordinary spectacle arises as the star's outer layers interact with gases and dust, creating a dazzling display that highlights the star's dynamic nature and its intricate dance with the cosmic backdrop. Studying Betelgeuse's bow shock not only provides insights into its current condition but also enhances our understanding of how stars evolve and lose mass over time. However, Betelgeuse's recent behavior has raised eyebrows among astronomers. Observations have revealed that its surface has cooled and become less dense since the ejection event, leaving the star in a precarious state even years later. Hydrodynamic simulations reveal the relationship between the star's motion, mass ejection, and subsequent changes in the emission mode. This coolness raises questions about the internal processes that bring about these changes and their consequences. In addition, the observed mass loss rate for Betelgeuse is significantly higher than for other stars, indicating a complex interaction of internal forces. This dynamic and unpredictable nature of Betelgeuse's life cycle challenges astronomers to rethink their models of stellar evolution. But amid all these dramatic changes, one question remains. Is Betelgeuse on the verge of a supernova explosion? This possibility has intrigued astronomers for centuries, but the exact time remains elusive. Recent studies suggest that this event will happen much faster than previously thought, perhaps within tens of thousands of years. While the timing is still unclear, a recent major launch has changed the debate, suggesting an end may be closer than previously thought. While astronomers are focused on Betelgeuse, another planetary event is gaining attention: the supernova SN 2023X. This spectacular explosion occurred in a spiral galaxy 21 million light-years away. Discovered in May 2023, SN 2023X is the closest supernova seen in recent memory, providing a priceless glimpse into the star's grand finale. The discovery of SN 2023X is an interesting parallel to the fate of Betelgeuse, as the two stars share similar characteristics. This discovery not only revealed the magnitude of stellar explosions, but also highlighted the importance of studying supernovae to improve our understanding of the mechanisms that drive them. The appearance of SN 2023X revived the astronomical community and sparked interest in pursuing these nefarious projects. Astronomers believe that Betelgeuse will end in a spectacular supernova explosion. When this happens, the supernova will lie in front of the entire Milky Way for weeks, shining bright enough to be seen from Earth during the day. This event leaves behind a neutron star or black hole, changing the night sky forever. Betelgeuse is one of the most famous stars in the sky, and its explosion may have caught the imagination of people around the world. Although the exact time of the supernova is uncertain, one thing is certain. At the end of the explosion of Betelgeuse, it was one of the most spectacular and important events in human history. Get ready for a front row seat to one of the most spectacular shows the world has to offer.